Welcome back to Introduction to Programming. During the course, I spoke about that at some point in time we will take the introductory C program and we will do the dissection of the program, and we will see that what each of these parts in the introduction program mean. I think that this is the right time, so let's just look at the anatomy of a basic C program. So let's just jump right in. So this is the basic hello world program. And now we want to see that what each of these construct, what is this hash include, why the int main is written like this, what is the purpose of this int over here, and what is the purpose of this return over here. So let's look at each of them one by one, but first let's understand some mathematics. So I'm assuming that you all are familiar with the concept of mathematical function. So mathematical function usually have a domain and a codomain. So for example, you can say that this function, so the f here, it goes from real number to real number. F here is the name of the function, but since f does not convey any particular meaning, I can write the function name as square, and I can say that it goes from real numbers to real number. So on this side, on the side of the domain, this defines the argument to the function. So you can see that this is a unary function. It takes one argument, and then the moment you provide the value of x, it gives the square of it. So that is the square function. Similarly, you can think about that functions can be binary as well. So this is just an addition function, which is a binary function, and all we are doing is that we take two numbers, we add them together. So this function also is essentially from real number cross real number to real number. So this function takes two arguments. It is a binary function. We have established that this is the codomain. So the value that is returned by that function, in some sense, that belongs to this domain, and the parameter of the function are defined by the sets that are specified over here. Okay, and this over here is just the name of the function. Now that we have this terminology, let's go back to our program. So over here you can see that this is int. Now this is the return type or the codomain. The main is the function. Technically it's not a mathematical function, it is a subroutine, it does something, but in C programming language lingo it is called a function. So I'm going to use the word function from now on to refer to a subroutine, and whenever required to distinguish between a mathematical function and a subroutine, I'll say explicitly mathematical function. So this, you can see that this is the codomain, this is the name. This apparently does not take any parameter, and this is right there that typically you expect that if a mathematical functions have some parameter. This return, what it does is that it returns the value. You compute something maybe based on the parameter, and now you return this value. So the type of this 0 over here, or whatever the value that is there in front of the return, that type should match with the type that you have specified over here. Now the next question is that what does return 0 mean? Why not some other value? Now traditionally the value of 0 in main, and when you return it, it indicates a normal termination of the program. If the program has some kind of anomaly, faces some glitch, then how does the program indicate to its caller that something has gone wrong? So typically a non-zero value is used to indicate that maybe something has gone wrong with the program. These are called exit codes or error codes. So maybe you can say that if I return 1, that means that maybe this is wrong. If I return 2, that means that something else is wrong, etc. So let's just see that where this value of 0 really goes. So by now you know that this is how we compile our function. So -o is an option or a flag, and that takes one more parameter, which is the name of the output executable, and this is the input file, and now we run the program. So it printed hello world, and now there is a doubt that what happened to the 0. We specified 0. So echo is a command in Linux. It prints a string, but if you pay attention to this $?, so $? is a special variable in the Linux shell. It is a placeholder for the exit code or the return code returned by the last command that got executed by the shell. So you can see that it says that the code returned by the last command was 0. Now let's say that you don't trust me. What if we try to return value of 5 over here? Is the shell really going to print the value of 5? Let's see. So I will again compile, I'll run the program, and now let's see that what was the code returned by the last command. You can see that the code returned by the last command is 5. Now typically the 0 indicates a normal termination and a non-zero value means that something has gone wrong. And that is why by default, if the non-zero value is returned, the caller of your program automatically assumes that something has gone wrong. So for example, in Linux, I can do this. So here I am using ZSH, but the syntax is similar to bash or bash. So I execute this command, and this is the OR, and in this shell the OR means that if the first command fails, only then run the next command. So see that it printed the program failed with exit code 5. Now there is another construct called end. So the semantics of that is that if your program succeeds, only then execute the next command. And you see that the understanding is that the program did not succeed because the value that was returned was non-zero. So that is the reason why we return 0. Let's see that what is this hash include stdio.h. Why is it required? Or can we do away without this file? So let's just see. So you comment out this hash include. I compile the code, and you can see that what has happened is that compiler has issued me a warning. It's not an error. So the program still compiled, it still produced an executable, but it gave a warning. What is that warning? It says that it uses an implicit declaration of function. Nowhere it is mentioned what printf is. This is entirely your program. You are saying printf. Instead of printf, I can see anything. I can just say blah blah. Let me try to compile again. And now you see that now it again gave a warning, and this error is not an error by the compiler, but this is an error by the linker. Okay, so what is a linker? Let's understand all the phases that your file goes through before the executable is produced. So your C file first goes through something that is called a preprocessor. Output of this preprocessor goes to compiler. Output of this compiler goes to assembler, and output of this assembler goes to linker, and then linker is the one that produces the executable output file. Now the process all the way till this point, this is done for every file. If your program is big, then you might have your program spread across multiple files. There are multiple C files, multiple header files, and all of these go through these phases, but the linker phase combines all of these things together. So there could be another C file, it goes through all of these phases, and then the output of the assembly of that comes here. It goes inside the linker. You combine all of that, and then what you have is the executable. So let's take a look at this particular C program. Now instead of stdio.h, I have a different file. I declare two variables, and then I invoke this function. What is this function? So here is the content. It says, it is just saying that there is a function with this name. This is, it defines its codomain, and this defines its domain. So it takes two int. So int cross int becomes its domain, and int it's its codomain. And this is the file which actually tells you that what this function does. So now let's add a flag for save temps. So what it is going to do is that it's going to take this file and it will run through all the stages apart from the linking stage. So it's going to produce output of this stage and this stage and this stage, and it will not run a linker because we are saying that compile only. So only finish till the assembly stage is done. And now this will have produced these files. So as you can see here, example.i is the output after the preprocessor stage. Example.s is the file that is immediately after the compiler proper is run, and example.o is the output of the assembler stage. So let's take a look at what example.i looks like. So after you run the preprocessor, what it has done is it has added the contents of this myaddition.h inside this. So let me open myaddition.h. So see that this single line over here is now part of this file. So it says that this is the declaration, and this is the code that gets emitted after you run your compiler proper. Now on top of this, assembler is run, and if you try to open that, this is not going to be human readable. So preprocessor, apart from just copy pasting all the contents, it does other things as well. For example, so look at these two special lines that starts with this hash symbol over here. So it says that define value of a space 3 and define space value of b is 5. And now you can see over here that instead of writing 3 and 5, what I have written is value of a, value of b. So these are called macros. And what preprocessor does is that whenever it sees this thing, it is just going to replace it by whatever comes after this space. So let's see that in action. You can see that this is now a is equal to 3 and b is equal to 3. Now if you think that this is an old file, let me do it again. Let me change the value over here to something else. So let's say this is 32 and this is 55. Let's compile it once more and open. And now you can see that value of a has now become 32 and value of b has now become 55. Now if you are wondering that what is the point of doing this thing, actually these macros allow us to use the same thing over and over again without hard coding any of the parts. So for example, you can say that number of days in a week, and now you might wonder that, well, number of days in a week never changes, so why should I bother? But what about number of days in a year? Now the number of days in a year changes depending upon whether something is a leap year or not. Imagine that in your program at multiple places, if you write 365, for leap year, if you want to compile and run the program, you have to change at all the places. But instead, this allows you to do it only at one place. In fact, you can do even better. So for example, you see that this value of a and value of b, I don't have to define it like this. I can define these macros on this command line itself. And now let's see that what has happened inside the output of the preprocessor. You can see that the value of a was 53, value of b is 65. So if you remember in earlier lectures that there was things like I or u int max, and those things I were using in all caps, those are the things actually defined in those header files. So for example, let's look at the limits.h, which actually contains all these limits like u int max, u int min, etc. You can see that it has u int max defined as this particular value. Similarly, you can see that there are other things that is defined like long max, long min, and things like that. So there are other construct of the preprocessors. So what does it mean? Here, if you look at it, if word size is equal to 64, then you define that long max is so and so. Otherwise, you define the long max as this number. So this is the 64-bit long and this is a 32-bit long. If you don't know the architecture, the size of int and long is going to depend on the architecture. And this is how they do the architecture specific compilation. So these thing is called conditional compilation. If the word size is 64, it defines this macro, otherwise it defines this macro, and so on and so forth. You cannot use a program variable. It has to be preprocessor time available macro or some such condition. So let me make my life easier again by defining this inside so that I don't have to type long commands on the command line. Now you might notice the difference that instead of angle brackets, what I am using is quotes. So by default, when you put the quotes around a file name, it says that search for this file on all the include paths and also in the present directory. If I put the angle bracket, so if I put the angle brackets, now see what happens. So it said that myaddition.h, no such file or directory. It just could not find where that file is, because as I said, if you include it, put a quote around it, it is going to search for that header also inside the present directory, the directory from which you are doing this process of compilation. If I want to fix it, then what I can do is that I can specify the directory in which it should look in addition to other things. And now you see that now this error has gone away. Also note that the order of definition matters here. So for example, if I define these macros instead of here, if I define this macros over here, it is not going to help. Now you see, now it says that it does not know what is the value of A, it does not know value of B. These are undeclared identifier. It's not uninitialized variable, which is legal in C, should not be done, but it is still legal. Whereas this is undeclared. This is something that I don't even know. It is not in my vocabulary. So that is why it is giving an error. So now we fix it. So now we have provided the path for myAddition.h. We have defined these things. Now see that I want to generate the full executable. And now it says that undefined reference to myAdd. What has happened over here is that this file, it just provides the signature of the function. What do I mean by signature of the function? The signature of the function is this. You are just specifying what is its domain and what is its codomain. You are not actually telling how that function can be computed. So it could not find the definition. Over here in the header file, what you have given is just a signature and a promise that at some point in time, at later, maybe from some another file, there will be a piece of the puzzle that I will give it to you so that you know all the instructions that is necessary to execute my program. So it is like a jigsaw puzzle. You have to provide some other file which fits inside this jigsaw puzzle and completes your program. And that part over here is this. myAddition.c is the file where you are actually defining that what this function does. It is just doing the addition. Just with signature, you take two number and you give back one number. You don't know what to do with these two number and what value to return at the end. I have to provide this myAddition.c as well. So what the compiler is going to do is that it is going to create all these. Both of the file will go through the stages of preprocessing, compilation, assembly, and then the linker will finish the jigsaw puzzle by stitching the correct parts together. And now you can see that it prints 88 because 35 plus 53 is 88. So now I hope that you have understood that your files goes through multiple stages and at the end the executable is produced. Also, if you remember, let's just recap that I can just put blah blah over here. Now blah blah is nowhere. So it is a piece of a jigsaw puzzle which is never going to come. And now you see that your compiler is giving a warning that this is an implicit function declaration. It still finished the compilation, but now the linker, this is LD is over here, is a linker. It is telling that I cannot find the remaining piece of the puzzle to generate the final executable. Now what happens in the C standard, implicit declaration of function is allowed, it is legal. What it is going to do is that it is going to assume that there will be a function named blah blah. It will take two parameters and then the return type will be int. It just assumes that implicitly. Especially for beginners, I would suggest that when you compile your program, you always add these two flags. You say that please give me warning for everything and please convert all warnings to error. See, what happens is that somebody tells you that if you go down this path again, you are going to meet a lion and it can potentially eat you. Now one thing you can do is that you can ignore that warning. You still go down that path in the jungle, be eaten by a lion, and then one can say that, I told you so. So these are the warnings. When the compiler thinks that you may be doing something that may make your program incorrect, it is giving you a warning. It is always a good idea to help the compiler help you by asking it to give not only more and more warnings, but you ask it that convert all warnings to errors. So error means that I just will not let you go in the jungle. It's not that I'm warning you and it's up to you if you want to go in the jungle or not. I will not let you go. If you do -w error, then even the compilation will fail. So you see that now what was a warning for implicit function declaration now has been converted to the error. For all the beginners out there, I would suggest you or earnestly request you to always use these two flags while compilation. Minus capital W ALL, that means that give me warning for everything, and minus capital W error, that means that all the warnings are converted to error. So I hope that you understood the anatomy of basic C program, what each of these parts do, what does return mean, what does this hash include mean, what does preprocessor do, and what all stages your files go through. Thank you very much.